Okay, let's lay out a 21-stage ring oscillator. And we'll do that by opening the library here. This was what we did in the last tutorial. We laid out we sketched the schematic of a 21-stage ring oscillator. Now I'm going to do a file save as CMOS EDU6 and go down and create a new cell. Call it layout ring oscillator 21. Now I'm going to turn the grid on, Control G. Now I can get quarter motion, half motion, or full motion, which is how I move things. I'm going to leave it on quarter motion. I'm going to take my inverter and I'm going to pull the layout of my inverter down into the cell here. Now if you can see the ports on the cell. If I want to see inside the cell, I don't use Control down or Control U. I view the contents of the cell. I'm not going to use that for the moment. I'm going to make my layout as quickly as possible, and then I'll make comments about making it nicer later. Now note, on all of my ports, the inputs and outputs are all on metal 1. So I'll leave that closed. Then I'm going to copy this, do a Control copy, then a Control V, and why don't I just line these up, hit fit, can view the cells. I probably will have a well spacing, but let's see what happens. Tool DRC, okay, no well spacing error there. But let's go ahead and hide those cells. And then I'm going to connect this output over to this input and connect this power over to here and so forth. I'm going to copy this, Control C, Control V, drop it down. Let's hit fit, and drop it down. Just use the outline of the cell. I'm being a little sloppy, but I'm trying to do it quickly. And then I can connect this node over here, fit, and then expand, and then I've got 4. I'm going to put them all in one line, so do a Control C, Control Z, Control paste, escape. Let's select those again, Control C, Control V. Zoom in just to make sure I aligned it right. I didn't. Fit. Let's do a quick DRC. 0 errors, 0 warnings. Let's tie this up here. 1, 2, 3, 4, 5, 6, 7, 8. Control C. Expand a little bit. Control V. Zoom in on here. Fit. Zoom in over here. Well, I guess I can do it from out here. Those are connected. Oh, you know what I haven't been connecting? I haven't been connecting my VDDs. So let me connect those up. Hopefully we won't have a DRC error there. And then connect the grounds up. So I'm left clicking to select and then right clicking to draw the piece of metal. And let's do a DRC, no errors. Let's go ahead and look at the layout so we can view it. And we see our lines going across. Let's turn the grid off for the moment so it looks a little nicer. And so we see our power's routed on the top and our ground is routed on the bottom. And we have 16, I believe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so let's go ahead and hide these again. Close this. And then let's do a Control V again for paste. And then expand. Just drop that in approximately where it needs to go. Zoom in on there. Off a little bit. Let's pull it in. Do a fit. And let's, from out here. And then let's tie that over. So again, I'm right clicking and dragging. Connect my power up. Oh, you know, on the very end there, I don't need all these inverters because I only need 21. So the last 3 I'm going to delete. Let's go delete those. And do an F5, no errors. Alright, so now I need to come back and connect this node here, up, around, over, and down. So there's my ring. Now I can export, Control E. This node is ground. Can export this node, Control E as VDD. Do a DRC again, F5. Do an LVS. All right, let's check the wells. No well errors. Let's do a DR or a NCC. Okay, I've got VDD and ground implied, of course, because I didn't use that in my schematic. So I've just laid out the entire ring oscillator. And I can view it now if I show the insides like this. But you know what? Let's clean this up a little bit because I don't like having the metal routed over like that. And just to show that it does fail, if we put that in, let's zoom in here. So there's our output. And then here's our input. We can go and add a node which is a metal 1 to metal 2 contact, or via rather. And whoops. Put this in here. Fit. Zoom. Zoom. Now I can connect that over here. My metal is tied. I can hit fit. And then I can go back over here, put that metal 1 to metal 2 contact. Drop that down. Come back in. I made a connection there. Now I can select metal 2, fit, and I can go here, select that, and then right click and drag it over, connect to there. Whoops, let's see, did I select? Oops, I just shorted everything together. So let's hit Control Z, fit. Let's zoom in here again. Zoom in. Let's select the metal 2 arc. And make sure that I pull that. Well, why is it selecting? Zoom, let's make sure. Oh, because I selected a poly and not a metal 1, metal 2 arc. Okay, so let's fix that. Let's get rid of that. Delete. Let's put the metal 1, metal 2 contact there. Pull it over. Let's make sure I didn't do the same thing on the other side. Zoom in. Zoom in, and I did. So let's get rid of that. And let's put our metal 1, metal 2 contact there. Pull it over. There we go. All right, zoom in here. Make sure that we're on the right place. Fit. Oops, fit. And then go here. And then right click over there. See if I selected the right node. Nope, I didn't, so Control Z. Oh, because I'm in metal 1 still. So let's select this, hit Fit, pull it over again. There. See what happened? All right. So I ran the connection back out on metal 2, which you can see going across. Let's hit Fit, do a DRC, 4 errors, probably too close here. The metal contact, let's shift through. Oh, I must have spaced those a little too close, there and there. Alright, so I must have shifted something inadvertently. So let's zoom in on that. Show the error again. Z. F5. 4 worms. 6. Let's not mess around with this. Let's hit Fit. F5. 4 errors. Shift through them. Okay, those are the errors right there. I must have put these a little too close, so we'll select those. Slide them on down a little. Hit F5. See if the errors are the same. Something's not right because I have the same spacing on everything except those. Why did I put those too close? Alright, well, this is a good time to go back, hide the insides because they do nothing but confuse me, and then look at the spacing here and go through. Oh, there it is. Alright, sure enough, I didn't align them properly. Okay, so let's move this one over. That's good to make mistakes. Learn from them. No errors. All right. So let's export the output here. And what did I call that in the... let's do an LVS real quick. And there's our VDD and ground implied. Let's go back over here and look at the schematic, and I called that export oscillator out. Let's go back, zoom down here, and select that, Control E, oscillator out. And did I call it uppercase there or not? Nope. Okay. Fit. Let's do an F5 again. Let's check the wells. Let's go ahead and now look at the layout. And then let's go back in and do a DRC one more time. No errors. So now we're ready to simulate this. And of course we don't make icons for layout. So let's make a new cell. And it's a layout. And we'll call this ring oscillator sim, and it'll be in this group right here. And so I'll go in here, select the text. Well, let's go ahead and put the cell in first. So I drop the ring oscillator layout in here in my sim cell. Fit, zoom in over here. I've got a connection here I got to connect to, connection here, and a connection here. Double click on there, and I'm going to call this VDD. So that arc, it's got a node name in Spice of VDD, and we can use the Control and Shift through and Control I and make it a little bigger. Let's go 3, apply, just so I can see it. Go down, we'll call this node oscillator out, properties, apply, properties, text size 3, apply, okay. And then this one we'll double click and call GND, apply, and then properties, height 3, okay. And the whole point of that is so that Well, I guess I should make it even bigger, but I can go back and change the text size. I'm not going to. Okay, and then the last thing we need to do before we sim is we need to copy the spice code here. Control copy, Control paste. It's kind of tiny, so let's make it bigger. 3, apply, and let's make it even bigger. 5, apply, and let's live it up and go with 10. Okay, so I can see it there. Yeah, let's go ahead because we want to be able to see this from the outside. We'll make that 10 as well. And this one we'll make 10, apply, and this one we'll make 10. Okay, so fit, we've got our cell, and we can then view the insides, and if we want to edit it, we can press Control D to go down in the hierarchy or Control U to go up. So let's go ahead and save this. And I did save this library as, nope, I already saved it as 6. Okay, so now let's generate our Spice netlist. And here we already did the layout. Notice I just pressed S there instead of going up to Write Splice Deck. I've made a key binding of S. Then I can go down now to the directory with that layout in it and plot V oscillator out. Now here's an interesting thing I alluded to earlier. If I go back and I look at the frequency, I open up the schematic and I compare that to the layout, I get a lot higher frequency. Notice it's the same time scale. And the reason is because in this schematic for the layout here, one of these, or in here, I've got, if you can see it, you can't see it, I've got the areas of the source and drain specified. I can make it even worse or even better depending on your perspective. I can lower the oscillation frequency even more if I go back to my preferences and my tools, and it is Spice, and I use Parasitics, which then will include all the parasitics of the metal, capacitance, substrate, etc., etc. Let's take a look at that. You can see the metal there. And then I can generate the Spice netlist. And this is lay with Parasitics. If I go back now and take a look at the oscillation frequency, see that's even lower oscillation frequency, but you can see all of the capacitances and resistances in the schematic. Okay, so we'll save these files and we'll save the 6. You can go in and on the next one we'll come back and talk about doing some basic layout and how to tighten things up and how to connect things together better, etc., and move these together, and how do I make nodes or lay things out in specific ways and all that stuff. But this should give us the basics at this point where we can do a layout of a more complicated circuit, draw an icon for it, draw a ring oscillator, etc. So let's go ahead and stop there.